Hello everyone, let's look over chapter 14, acids and bases. So acid have the following properties. Acid have a sour taste. Acid dissolve many metals. It turns blue litmus paper red. There are some common acid. For example, hydrochloric acid, sulfuric acid, nitric acid, acetic acid, carbonic acid, hydrofluoric acid. Bases have the following properties. Bases have the bitter taste, slippery feel. Bases turns red litmus paper blue. There are common uh, bases. Sodium hydroxide, potassium hydroxide, sodium bicarbonate, ammonia. First, we need to know definition of areneous. So, areneous acid. The acid produces hydrogen ion in aqueous solution. So HCl is covalent compound, does not contain ions. In water, HCl ionized to form hydrogen ions and chloride ion. Hydrogen ions are highly reactive. In aqueous solution, they bond to water molecules within the reactions. So hydronium ion is hydronium ion. The chemistry is often use hydrogen ion and hydronium ion interchangeably to refer to hydronium ion. In the molecular formula for acid, we often write ionizable hydrogen first. So for example, we write a formula for formic acid HCHO2. The first H is ionizable hydrogen. Second H is non-ionizable hydrogen. We represent structure of the formic acid with its structure formula. Structure formula indicate how atoms are bonded together. This is an example of formic acid structure formula. So this hydrogen is ionizable hydrogen. This is non-ionizable hydrogen. Next, we need to know definition of the base. The base is a base produces hydroxide ion in aqueous solution. NaOH is areneous base because it produces hydroxide ion in the solution. NaOH is ionic compound, contains sodium ion and hydroxide ion. When NaOH is added to water, it dissociates into its component ion. For example, sodium ion and hydroxide ion. Molecular compounds contain an OH group, such as methanol CH3OH, do not dissociate in solution. Therefore, do not act as a basis. Under Arrhenius definitions, acid and base naturally combine to form water, neutralizing each other in the processes. There are two limitations in Arrhenius definition of acid and base. Arrhenius definition of acid and bases cannot explain why some substances act as bases even though they do not contain hydroxide ion. For example, NH3. This is the base, but there's no OH group. Arrhenius definition does not apply to non-aqueous solvent. There are two limitations in Arrhenius acid-base definition. So, when you see Bronsted definition of Arrhenius definition of acid bases apply to wide range of acid base phenomena. Definition focus on transfer of hydrogen ion in acid base reaction. An acid is proton donor, a base is a proton acceptor. So ammonia with dihydrogen monoxide to generate ammonium ion hydroxide. So there are two hydrogen in the reactant. After reaction, you can see one hydrogen. So this is a proton donor. This one is acid. Ammonia, three hydrogen. After reaction, you can see four hydrogen. That's proton acceptor, that's base. In the reaction between HCl and H2O, HCl is proton donor, H2O is proton acceptor. So H2O is base, HCl is acid. In the reaction between ammonia and water, water is the proton donor and ammonia is proton acceptor. So NH3 is base, H2O is acid. Some substances such as water can act as acid or base, either accepting or donating proton. So substances can act as acid or bases are amphoteric. In the chemical equation, ammonia react with dihydrogen monoxide to generate ammonium and hydroxide. Ammonium and ammonia are often referred to conjugate acid-base pair. Two substances relate to each other by transfer of the proton. Also, H2O and OH minus, this second conjugate acid-base pair. In this reaction, there are two conjugate acid-base pairs. Ammonium, ammonia, dihydrogen monoxide, and hydroxide. In acid-base reaction, the base accept the proton become conjugate acid. An acid donate the proton becomes a conjugate base. When acid and base are mixed, the hydrogen ion from the acid combine with hydroxide ion from the base to form the water. Acid-base reactions generally form water and salt. Salt is an ionic compound. Salt contains the cation from the base. You can see in this case potassium and anion from the acid Cl. So you can make a salt KCl. Acid-base titration is a way to quantify amount of acid or base in the solution. Solution stoichiometry can be applied to a common lab procedure called titration. In a titration, substance in a solution known concentration is removed with another substance in a solution of unknown concentration. In the acid-base reaction between hydrochloric acid, sodium hydroxide, the net ion equation is hydrogen ion react with hydroxide ion to generate dihydrogen monoxide. When you see representation of the acid-base titration, so you can slowly add solution of a known concentration of the solution of unknown concentration in the flask. So in general, it's known concentration, the base, unknown concentration, acid. At equivalent point, neither reactant is present in excess. The number of mole of reactants are led by reaction symmetry. As hydroxide is added, it reacts with and neutralizes hydrogen ion, forming water. At equivalent point, the point in the titration when number of mole of hydroxide added equals number of mole of hydrogen ion originally in the solution. So equivalent point is usually signaled by indicator. So in the titration, NaOH is added to HCl solution. You can add NaOH into acid solution. When NaOH and HCl reach symmetric proportions, indicator, you might use phenolphthalein as an indicator, change to pink, signaling equivalent point of the titration. Phenolphthalein is an indicator is calories in acid solution. Now can you see calories in acid solution? And pink in basic solution. Okay. Let's see acid-base titration calculation. Titration of 10.00 milliliter of HCl solution of unknown concentration require 12.54 milliliter of 0.1.00 molarity energy solution to reach equivalent point. So let's calculate concentration of unknown HCl solution. So first, what are the givens? So you can see 10.00 milliliter of HCl solution and 12.54 milliliter of 0.100 molarity of NH solution. So first, it is good to create balanced equation. So 1 mole of HCl react with 1 mole of sodium hydroxide to generate 1 mole of dihydrogen monoxide and 1 mole of sodium chloride. So create balanced equation first. And then, so write down given number in unit. So given number in unit, 12.54 milliliter NaOH. So you have to convert milliliter to liters. So times 1 liter over 1000 milliliters. So unit cancel out. Then use information given number of molarity. So 0.100 molarity means 0.100 more NaOH over 1 liter NaOH. So liter cancel out, you can get more over NaOH. To calculate concentration of HCl, we need mole of HCl. So convert more NaOH to more HCl. We need mole ratio from chemical equation. To get mole ratio, you need to create balance equation. So 1 mole of hydrochloric acid react with 1 mole of NaOH. So 1 to 1 ratio. 1 to 1 ratio. So mole cancel out. You can get mole of HCl. To calculate molarity of HCl, we calculate mole of HCl. Next, what is given? That's 10.00 milliliter HCl. You have to convert milliliter to liters. So when you convert milliliter to liters, you can go see 0.010000 liters. For significant figures, there are 4 significant figures. Okay. And then finally, you can get molarity of HCl, 0.125 molarity of HCl. It's very important, okay? You might see similar question, essay-based calculation in quiz and exams, okay? So, strong and weak acids and bases. Strong acid. When HCl dissolve in water, it completely ionizes into hydronium and chloride ions. So solution contains no intact HCl. Weak acid, when HF dissolves in water, only fraction of the dissolved molecules ionize into hydronium ion and fluoride ions. The solution contains many intact HF molecules. So when you see chemical equation, hydrochloric acid with dihydrogen monoxide to generate hydronium ion and chloride ion. You can see single arrow. What does it mean? Single arrow indicate complete ionization. Okay, that strong acid. Hydrofluoric acid react with dihydrogen monoxide to generate hydronium ion and fluoride ion. You can see double arrows. What does it mean? You can see that's a partial ionization. Okay, conductivity of the strong weak electrolyte. So A, so pure water will not conduct electricity. So B, hydrofluoric solution contains some ions, but most of the HF is intact. The light glows only dimly. The presence of the ions in HJ solution resulting in conduction of the electricity, causing light bulb to light in HCl solution. So this is weak acid, this is strong acid. Let's see table of strong acid. There are 6 strong acid. Okay, hydrochloric acid, hydrobromuric acid, hydroiodic acid, nitric acid, perchloric acid, sulfuric acid. So 6 substances are considered strong acid in aqueous solution. 5 acid in the table monoprotic acid. What does mono mean? That the one, okay? Acid containing only one ionized proton. For example, HCl. HBr, HR, HNO3, HClO4. You can see only one ionizable hydrogen. That's monoprotic acid. So there are 5 strong monoprotic acid, HCl, HBr, HR, HNO3, HCO4. And sulfuric acid is an example of a diprotic acid. What does di mean? 2. So acid contains 2 ionizable proton. So now can you say H2SO4? There are 2 ionizable hydrogen. So what is a strong diprotic acid? You need to know sulfuric acid. Okay. So some common weak acid, HF, acetic acid, formic acid, sulfurous acid, carbonic acid, phosphoric acid. So first, you have to memorize 6 strong acid. Then rest of them, weak acid. You understand? It's very important to memorize 6 strong acid. So what is the hydronium concentration in solution? So 1.5 molarity of HCl. So HCl is strong acid. What does it mean? It completely ionizes. So concentration of hydronium ion will be 1.5 molarity, the same. Okay. What about 3.0 molarity of acetic acid? So memorize 6 strong acids, right? This is not 6 strong acid, one of the 6 strong acid. So since acetic acid is weak acid, it partially ionized. What does it mean? It will be less than 3.0 molarity. Okay, also memorize 6 strong bases. So lithium hydroxide, sodium hydroxide, potassium hydroxide, strontium hydroxide, calcium hydroxide, barium hydroxide. So, produces hydroxide ion in water. That's base, right? But memorize six strong bases. So weak base, when ammonia dissolved in water, it partially ionized to form ammonium ion and hydroxide ion. However, only fraction of molecule ionize. Most molecules remain as ammonia. There are many weak bases. Only amines are weak bases. So when you see nitrogen, we can call it as amine. So for example, NH3, C5H5N, N, N. Okay, we're going to amines are weak bases. Also, bicarbonate ion, that's a weak base. Okay, what is the hydroxide ion concentration in each solution? So 2.25 molarity of KOH. So KOH is one of the six strong acid. So what does it mean? It comfortably dissociate into potassium ion and hydroxide ion in solution. So concentration of hydroxide is 2.25 molarity. And then second one, 0.35 molarity methylamine. So methylamine is a weak base. What does it mean? It is less than 0.35 molarity. So water is amphoteric. It can't act either on acid or base. Even in pure water, water acts as an acid and base with itself, a process called self-ionization. When you see the equation, 1 mole of water will with 1 mole of water to generate 1 mole of hydronium ion and 1 mole of hydroxide. So in this case, there are two hydrogen. After reaction, you can see one hydrogen. So proton donor, that's acid. Second, dihydrogen monoxide. There are two hydrogen. After reaction, you can see three hydrogen. So proton acceptor, this is base. So water acting as both as an acid and a base. So empathetic. So for pure water at 25 degrees Celsius, concentration of hydronium ion equals concentration of hydroxide equals 1.0 times 10 to the negative 7 molarity. Memorize, okay, concentration of hydronium, concentration of hydroxide at 25 degrees Celsius. Ion product constant for water, Kw, equals concentration of hydronium times concentration of hydroxide. So insert number and unit, and then you can get 1.0 times 10 to the negative 14. That's Kw. So 1.0 times 10 to the 14, negative 14. Memorize Kw. So in neutral solution, concentration of hydronium hydroxide equals 1.0 times 10 to the negative 7 molarity. In acid solution, concentration of hydronium is greater than 1.0 times 10 to the negative 7 molarity. Concentration of hydroxide is less than 1.0 times 10 to the negative 7 molarity. What about basic solution? Concentration of hydronium is less than 1.0 times 10 to the negative 7 molarity. Concentration of hydroxide is greater than 1.0 times 10 to the negative 7. So all aqueous solution memorize equation. Okay, 1.0 times 10 to the negative 14. So let's solve problems. Calculate concentration of hydroxide. The solution determine whether solution is acid, base, or neutral. What are the givens? Concentration of hydronium, and then concentration of hydronium times concentration of hydroxide equals 1.0 times 10 to the negative 14. You have to memorize, define relationship. Okay. And then let's insert concentration of hydronium in here. Then when you solve problem, you can get concentration hydroxide 1.3 times 10 to the negative 10th molarity. So concentration hydronium is greater than concentration hydroxide. So that's an acidic solution. So pH and pH scales are ways to express acidity, basicity. So at 25 degrees Celsius, pH is less than 7. That's acidic solution. pH is greater than 7. That's basic solution. pH equals 7. That's neutral solution. You can calculate pH values. pH equals negative low concentration of hydronium. Also, you need to memorize to define relations pH plus pOH equals 14.00. Also, you need to memorize pOH equals negative log concentration of hydroxide ion. Okay, three defined relationship memorize. So, calculate pH of a solution indicate whether solution is acid or basic. What is given? Concentration of hydronium equals 1.8 times 10 to the negative 4 molarity. So use define relation pH equals minus low concentration of hydronium. Insert number and calculate. You can get pH equals 3.74. So pH less than 7. What does it mean? Acidic. Okay, acidic solution. Next, calculate pOH solution and indicate whether solution acid or basic. What is given? Concentration of hydroxide equals 1.8 times 10 to the negative 4th molarity. So insert given number in define relationship. So pOH equals 3.74. Use define relationship to calculate pH. So 14.00 minus 3.374 equals 10.26. So pH is greater than 7. So what does it mean? Solution is the basic. Okay, we need to know definition of the purpose. Purpose are solution resist pH change. Purpose contains significant amount of the both a weak acid and its conjugate base. So weak acid neutralize added base, and conjugate base neutralize added acid. For example, human blood is a buffer. In healthy individuals, blood pH between 3.36 and 7.40. If blood pH were to drop below 7.0 or rise, okay, above 7.8, that's good result. Okay, thank you for watching video.